Okay, so here we are then with the answer to yesterday's cliffhanger. I wonder if you got it right. I added another row to my Pascal's triangle, and I had the pattern of powers of A, A5, A4, A3, A2, A1, no A at all. And I had the pattern in the powers of B, no B, B to the 1, B squared, B cubed, B to the power of 4, B to the power of 5, and then the coefficients were there, 1, 5, 10, 10, 5, 1. So what we're doing is, in this little mini topic, is we are looking at expanding things that look like this without having to go through all of this malarkey. And as I said yesterday, the sort of title for this work is the binomial expansion. So this is all about expanding things that look like this, two numbers in a bracket, binomial, and it is about the fact that there is a predictability, which means that we can do it really quickly. So let's look at some examples, and then tomorrow I'm going to set you some work to do independently. Just to explain why we're only doing 3 lessons this week, one group only has 3 lessons this week because they would have had maths on Monday. The other group, you have 4 lessons. I don't want the two groups to sort of separate. I want everyone to be doing the same thing because it would be a bit of a nightmare for me. So that's why I've stuck with 3 taught lessons this week, plus 1 homework task, independent lesson, call it what you will. And then next week we'll go to 4 lessons. The first lesson you can either do on Monday or Tuesday, depending on which group you're in, and then it'll be Wednesday, Thursday, Friday for everyone. So yeah, I'm really keen that you stick to your timetable, and I realise that for group 12E this week's been a little bit disrupted, but hopefully we can get into the routine. Okay, so first example. Let's go back to one we've already done, but we've done it the long way, and I'm keen that we do it the quick way. The sun has just come out, which is why everything's gone a bit blue, but there we go. What a lovely day. Now, of course, I already know the answer. I've already done it, but I did it the long way. So I'm hoping we can get this using the quick way. So I know powers of this are going to start at that number and go down. A to the power of 1, not going to put the 1. And then I know there's a term here with no A at all. I know powers of B are going to increase, starting with no B at all here, and then B to the power of 1, B squared, B cubed. And then I know the coefficients, the numbers in front, I get those from Pascal's triangle. I've got 4 terms in this expansion, so I need 4 coefficients. So I just look at the row that's got 4 coefficients in, 1, 3, 3, 1. So that's 1, 3, 3, 1. And then those terms are added together. And, okay, I'm going to write it out in a line now. Now, you may say, why didn't you just go straight to this? Why did you do this? Well, because this number is going to get a lot bigger. And I think working like this makes it a whole lot easier. So, okay, have a go at this one. So that's the way I did A plus B cubed. So have a go at A plus B to the power of 4. See if you can set it out going down. I'll pause the video with my copy of Pascal's triangle there, but you might want to knock up your own version. Just see if you can do that one for me. Okay, so powers of A start at A to the power of 4 this time and go down, and we have a term here with no A at all. Powers of B increase, starting with no B's and then B to the power of 1, B squared, B cubed, B to the power of 4. 5 terms in that expansion, so I'm looking for the row with 5 numbers in it, so it's 1, 4, 6, 4, 1, and those terms are added together. So my answer is a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the power of 4. And we already knew that, didn't we? We'd already done that. There we go. We had that answer there. Same answer, but this time we did it really quickly using this binomial expansion method. Right, do you want to have a go at this one? Press pause and have a go. Okay, so hopefully you got that all right. And of course we'd already done that the long way. That's where we started today's video. But we've done this really quickly using this binomial expansion method. It's rich with patterns. We've got, for example, the whole Pascal's triangle thing, but look at the powers. If you add the powers of a and b together in each term, you get this number here. So that's 5, 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4, and 5. So there's all sorts of patterns going on here. Right, what's the point? Why do we need to be able to do this? Well, we need to be able to do this because sometimes we want to expand things like this quickly. And if I was asked to expand this, I would do it as a two-step process. Now, some of you will quickly be able to dispense with the first step, but bear with me. So I would say, right, okay, what does that look like? A plus b cubed, I know, looks like this. A cubed, a squared, a, no b, b, b squared, b cubed. 4 terms, so that's the line in Pascal's triangle with 4 numbers in it, 1, 3, 3, 1. Okay, I'm not going to write it out lengthwise because what I'm actually trying to do is this. So what I now need to do is I now need to make a equal to 2 and b equal to 3x. So that gives me, I might change colour, that gives me 2 cubed, and I don't need the brackets, but I'm going to put them in there, you'll perhaps see why in a minute, plus 3 times 2 squared times 3x. So all I've done is rewritten that term, but I've replaced a with 2 and b with 3x, giving me that, plus 3 times 2 times 3x squared, plus 3x to the power of 3. Now it looks like a bit of a dog's dinner at the moment, doesn't it? You know, this was quite nice, there's a pattern here, but as soon as you start replacing a's and b's, it looks like a bit of a mess. So now we've got to sort of unpick it, and we've got to be particularly careful when we come to this, this term here and this term here. So 2 cubed, okay, I can do that in my head, that's 8. So here I've got 3 times 4, 2 squared is 4, 3 times 4 times 3x. So 3 times 4 is 12, so that's 36x. Here I've got 3 times 2, that's 6. Now 3x squared, I'm going to make a little note down here. Don't forget that is 3x times 3x. So that's 9x squared. Really important that you get that bit right. Okay, so going back here, I've got 3 times 2, which is 6, times 9x squared, so that's 54x squared. And then 3x cubed, that's 3x times 3x times 3x. 3 times 3 times 3 is 27, so that's 27x cubed. So, and that term got its own, so that's. So I was asked to do this, but started by doing that, and then replaced my a and b with 2 and 3x. Let's try a slightly harder example. Okay, here's the next one then. It's to the power of 4. So I've already done a plus b to the power of 4. We've done that already, so there wasn't any point getting you to do that again. But what I want you to now do is to rewrite that, replacing a with 4 and b with minus 2x. And I hope big alarm bells are going off in your head already, because you realise that there's potential for mistakes there. B is not 2x, it's minus 2x. So go on, have a go. See if you can rewrite this, replacing a with 4 and b with minus 2x. And then see if you can simplify it to get a final answer. Okay, so I've done that, made a bit of a mess here, but that's, so that's that term, that's 4 times a cubed times b, so that's 4 times 4 cubed times minus 2x. And I'm not afraid to admit that I reached from a calculator, so I've done some worked out on the calculator. So 4 cubed 256. Sorry, not 4 cubed, 4 to the power of 4, 256. 4 times 4 cubed, that's 256 again, and that's times minus 2x, so that's minus 512x. Here I've got 6 times 16. Now minus 2x squared is going to be 4x squared, because minus 2 times minus 2 is plus 4. So that's 6 times 16 times 4, which is 384x squared. I've got 4 times 4 minus 2x cubed will be minus 8x cubed. Minus 2 times minus 2 times minus 2 is minus 8. So that's 4 times 4 times minus 8, which is minus 128x cubed. And then minus 2x to the power of 4, that's minus 2x times minus 2x times minus 2x times minus 2x is plus 16x to the power of 4. Now, did you notice that it said something here in ascending powers of x? I didn't mention it at the beginning, but let's just check we've got that. We have, haven't we? We've got no powers of x, x to the power of 1, x squared, x cubed, x to the power of 4. And they just put that in to make it easier to mark, so that, everyone's writing it in the same order. That's all. Let's try a harder one. Now, these binomial expansions get pretty long, and you might already have realised that the number of terms is always one more than the power. So if I was to do the full expansion of this, I'd have 7 terms. So that's why often you're asked to find just the first 3 terms, or the first 2 terms, or 4 terms, just to demonstrate that you can actually use the process. And, that makes it a little bit easier, doesn't it? So a plus b to the power of 6. Start by seeing if you can write out the first 3 terms only of that expansion. Do that bit for me first. Okay, so I started with a to the power of 6, a to the power of 5, a to the power of 4, no b, b to the power of 1, b to the power of 2. I knew that if I did the full expansion, because it's to the power of 6, there would be 7 terms. So I needed the row in Pascal's triangle with 7 terms, which is this one here. So it's going to go 1, 6, 15. It would carry on, but we're only asked for the first 3 terms. Okay, so now, next step, I'm just going to replace a with 3 and b with minus 2x. And again, alarm bells should be ringing. Go on, see if you can bring this one home. Okay, so 3 to the power of 6, which is 729. I don't think I'm super clever. I'm using my calculator, I'm not afraid to do that. 6 times 3 to the power of 5 times minus 2. 6 times 3 to the power of 5 times minus 2, minus 2916. So that's minus 2916x. And this is 15 times 3 to the power of 4. I know this is going to be 4x squared plus 4, because minus 2 times minus 2 is plus 4. So 15 times 3 to the power of 4 times 4, 4860 x squared. So I've done the first three terms. Let's just check. Have I got ascending powers of x? X powers of x getting bigger? Yeah, no x. X power of 1. X power of 2. Good stuff. Okay, let's just try one tricky one before we finish today's lesson. And I'm just going to leave you to have a go at this and show you the solution in just a moment. Start off by doing a plus b to the power of 5. And then you're going to replace a with x and b with 1 over x. And there's just a little bit more simplifying to do at the end with this one. See how you get on. Okay, first three terms. So did that, realised that with power of 5 I was going to have 6 terms, so I needed the row of Pascal's triangle with 6 terms, that one. So it was 1, 5, 10. Don't forget, this isn't the full expansion, so I'm in a little dot, dot, dot to show that that's just the start. I then replaced a with x and b with 1 over x, so didn't really feel I needed the brackets around my a's. So a to the power of 5, a to the power of 4, a to the power of 3. No b, b on its own, b squared. 1 over x squared is 1 times 1 is 1, x times x is x squared, it's 1 over x squared. So the first term is a to the power of 5. If I multiplied this out, 5x to the power of 4 times 1 over x, I could write it like that. 5x to the power of 4 over x. So be confident that that becomes that, and hopefully you could see that I could then cancel out that x with one of those. So you get 5x cubed. And here, remember this is 1 over x squared. So I get 10 times x cubed times 1 over x squared, which I could write like that. And then hopefully you can see that I can cancel out 2 of those with 1 of those. So you just get left with 10x. Sorry, my focus is mucking about today. Sorry if it's a bit blurry. Anyway, I hope that you are able to see how that works. So what I'll do for Friday is I will give you just a few questions of this type to try, and I'm going to ask you to complete those as a homework task. So rather than having a deadline, I'm going to say do them on Friday in the time that you would have had a maths lesson on Friday. Submit them straight away. I can mark it over the weekend, and that will inform where we go with this next week. So next week, first lesson will be either Monday or Tuesday, depending on which group you're in, and we'll have a normal week with 4 lessons. That is the routine that we will have to get into over these next few weeks. I'm really grateful to those of you who have already got in touch and asked questions. I need you to, be as willing to ask a question by email as you would put your hand up in lessons. I rely on that. So I know that, the pace is okay. Maybe I need to go back and do something again. So yeah, please keep in touch, and I hope you're all well. Take care.